everyone. Today we'll discuss about understanding distribution shape in data analysis. It is visualizing data distribution is really important. The shape reveals the key insights of the whole population or the data you have taken for the analysis. It also helps us analyze the methods. Now I'll be discussing about symmetry and skewness. Symmetry is the data which is evenly distributed around the mean, meaning the left side of the distribution is an exact mirror image of the right side. A classic example can be said as the normal distribution curve, which is a bell-shaped curve. Now we'll discuss about what skewness is. Skewness is the statistical measure which qualifies the asymmetry of the probability distribution. It indicates the extent to which the data is concentrated at one side of the graph, implying a tail on the other. There are two types of skewness: right skewness, that is positive skewness, and left skewness, that is negative skewness. Now we'll discuss about right skewness. It is characterized by a long tail extended towards the left side of the distribution. Right side of the distribution, sorry. This means that the majority of the data points are concentrated to the left and the fewer larger value points pull the mean towards the right. An everyday example is the income distribution where most individuals earn less but a small number of high earners significantly inflate the average income. Now we'll discuss about left skewness, that is negative skewness. It is indicated by a long tail extending towards the left and the data points are concentrated at the right of the graph with the fewer smaller values pulling towards the left. A common real world example is the age at which people die. Especially in developed countries, most people live to an older age with a few individuals unfortunately dying at a younger age. Now let's understand taking an example of both right skew and left skew. Right skew example can be taken as house prices. Most homes are concentrated at moderate price points. However, small number of luxury properties extend the tail towards the right, pulling the average higher and creating the right skew distribution. Left skewness. Real world example for left skewness can be taken as the exam scores. That is, most students perform well, but only few students perform poorly. This result is a left skewed distribution. Now let's go to what is kurtosis. That is the peak and the tails. Kurtosis is the measure Kurtosis measures the tailedness of the distribution. Now we have various type of cortex. Leptocortic. Leptocortic means the high peak and heavy tails. This indicates more outliners. As an example, stock market returns with few small changes and occasional large swings. Pleocortic. Flat peak and thin tails means fewer outliers. Example, uniformly distribution or equal probability. Leptokurtic real world example can be taken as daily temperature which remains consistent. However, the rare extreme waves or cold snaps occur which disturbs the whole distribution. Pleokurtic real world example can be taken as rolling of a die. Each number 1 to 6 has equal chances of appearing. That is, the results of the pleokurtic are equally distributed. Modality. Modality means the peaks in the data, that is, the tip of the graph. There are three types of modalities: unimodal, bimodal, and multimodal. Unimodal features one distinct peak. A normal distribution is a classic example. Bimodal has two distinct peaks, combining, for example, height of women and men creates a bimodal distribution. Multimodal presents multiple peaks in the same graph. The age distribution in the diverse community with distant age groups shows this. Conclusion. Why distribution of sheep matters. Understanding distribution of sheep is crucial because it helps us appropriate statistical tests. This leads to deeper insights and ultimately informed decision making.